Hello, chemistry notes in full hours. Today we are come up with electrochemistry. Electrochemistry is very important chapter in chemistry. What is electrolysis? Electrolysis is the process of decomposition of an electrolyte by the passage of electricity through its aqueous solution or molten state solution. Faraday's first law of electrolysis. In a chemical reaction, the amount of any substance deposited or liberated is directly proportional to the quantity of electricity passed through it. That is, W is directly proportional to Q. W is equal to ZQ. W is equal to ZIT, where Q is equal to I into T, and Z is electrochemical equivalent. Z is also equal to atomic weight divided by NF, where N is number of electrons, F is equal to 96500, that is 96,500. Faraday second law of electrolysis. When the same quantity of electricity is passed through the different electrolyte connected in series, the weight of the substance produced at the electrodes are directly proportional to their equivalent weights. Example: AgNO2 and CuSO4 solution connected in series. Weight of Ag deposited divided by weight of Cu deposited is equal to equivalent weight of Ag divided by equivalent weight of Cu. Conductance of electrolytic solution. Electrolytes conducts electricity by decomposition. Electrical resistance. If voltage V is applied to the ends of the conductor and current I flow through it, then the resistance R of the conductor is V divided by I ohms. Electrical conductance. The reciprocal of electrical resistance is called conductance. I repeat, the reciprocal of electrical resistance is called conductance and is represented by G sign. Thus, G is equal to I divided by R. Unit of G is mho. Specific resistance or resistivity. It is observed that R is directly proportional to 1 and R is equal to I by A, or R is equal to rho I by A, where R is constant and called as resistivity. Specific conductance or conductivity. The reciprocal of resistivity is called conductivity and is denoted by K kappa. R is equal to 1 by G or rho is equal to 1 by K. As we know, R is equal to rho 1 by A. From these above two equations, we get 1 by G is equal to 1 by K into 1 by A. So, K is equal to G into 1 by A. Now we are going to discuss equivalent conductivity. Equivalent conductivity of a solution at a dilution V is defined as the conductance of all the ions produced from 1 gram equivalent of the electrolyte dissolved in V centimeter cube of the solution. When the distance between the electrode is 1 centimeter and area of the electrode is so large, then whole the solution is come between them. So, molar conductivity is equal to K into 1000 divided by C, where C is molar concentration. Calros law. The limiting molar conductivity of an electrolyte, that is molar conductivity at infinite dilution, is the sum of the limiting ionic conductivities of the cation and anion, each multiplied with the number of ions present in one formula unit of the electrolyte. Colera's law in terms of equivalent conductivity. The equivalent conductivity of an electrolyte at infinite dilution is the sum of two values. One depends upon cation and another depends upon anion. Dear friends, you can visit our website www.chemistrynotesinfo.com and under 12th class section you get notes of this chapter. Electrode potential. The electrical potential difference set up between metals and its ions in the solution is called electrode potential. Cell potential or EMF of a cell. The difference between the electrode potential of the two half cells is known as cell potential or cell voltage. It is called electromotive force or EMF of the cell if no current is drawn from the cell. Electrochemical series. The various electrodes have have arranged in order of their increasing value of standard reduction potential. This arrangement is called electrochemical series. Dear friends, you can visit our website to download electrochemical series images, and you can also visit our Telegram channel to download notes of this chapter in PDF format. Next equation for electrode potential. Mn plus Ne minus gives M. That is, then next equation is E is equal to E0 minus RT divided by NF ln M divided by Mn plus, where E is electrode potential under given concentration of Mn plus ions and temperature T. E0 is standard electrode potential. R is gas constant. T is temperature in Kelvin. F is 1 Faraday. N is equal to number of electrons involved in electrode reaction. Also put R is equal to 8.314 joule kilo inverse mole inverse. F is equal to 96500 coulombs. T is equal to 298 Kelvin. We get E is equal to E0 minus 0.0591 divided by N log 1 divided by Mn plus. Now we are going to discuss primary cells, and first is dry cell. It consists of a cylindrical zinc container which acts as a anode. A graphite rod is placed between the center, act as cathode. The space between the cathode and the anode is so packed with the paste of NH4Cl and ZnCl2, and graphite is surrounded by MnO2 and carbon. The reactions that occur at anode is Zn in solid forms gives Zn2 plus in aqueous form plus 2 electron. At cathode, reaction occurs as 2MnO2 in solid form plus 2NH4 plus in aqueous form plus 2 electrons gives Mn2O3 in solid form plus 2NH3 in gas and H2O. These cells have voltage in the range of 1.25 volt to 1.50 volt, have no long life. Mercury cell or rubber Mallory cell. It consists of zinc container as anode, a carbon rod as cathode, and a paste of mercuric oxide mixed with KOH as the electrolyte. A lining of porous paper separates the electrolyte from zinc container. Cell reactions that occurs at anode is Zn plus 2OH minus ions gives ZnO plus H2O plus 2 electron. At cathode, HgO plus H2O plus 2 electron gives Hg plus 2OH minus. Secondary cells. Lead storage battery. Cells consist of lead anode and a grid of lead packed with lead dioxide act as lead cathode. These electrodes are arranged alternatively, separated by fiberglass sheet and suspended in sulfuric acid dilute, which acts as electrolyte. Electrode reaction occurring during discharging of battery. At anode, Pb plus SO4 2 minus gives PbSO4 plus 2 electron. At cathode, PbO2 plus SO4 2 minus plus 4H plus 2 electron gives PbSO4 plus 2H2O. In above reaction, H2SO4 is used, hence density of H2SO4 is decreased, so battery will discharge. During charging, the electrode reaction is reversed. That is, PbSO4 plus 2 electron gives Pb plus SO4 2 minus, and PbSO4 plus 2H2O gives PbO2 plus SO4 2 minus plus 4H plus 2 electron. Then nickel cadmium storage cell. It consists of cadmium electrode as anode and metal grid of nickel oxide as cathode, immersed in KOH solution. Reaction occurring during discharge of cell at anode is Cd plus 2OH minus gives CdOH2 plus 2 electron. At cathode, NiO2 plus 2H2O plus 2 electron gives NiOH2 plus 2OH minus. Hence, the reaction can be reversed during charging. The potential of each nickel cadmium cell is approximately 1.4 volt. Fuel cell. It consists of porous carbon electrodes containing suitable catalyst incorporated in them. Concentrated KOH or NaOH solution is placed between the electrodes to act as the electrolyte. The hydrogen or oxygen gas are bubbled through the porous electrode into the KOH and NaOH solution. Reactions at anode is 2H2 plus 4OH minus gives 4H2O plus 4 electron. At cathode, O2 plus 2H2O plus 4 electron gives 4OH minus. Corrosion. Corrosion is the process of slowly eating away of metal due to attack of atmospheric gases on the surface of metal, resulting into the formation of compounds such as oxides, sulfides, carbonates, sulfates, etc. is called as corrosion. In corrosion, the metal is oxidized by loss of electrons to oxygen and formation of oxides. The corrosion of iron occurs in the presence of air and water. In iron sheet or objects or a particular pot behaves like where oxides take place. Their oxidation takes place. At anode, 2Fe gives 2Fe2 plus 4 electron, and these electrons move to another spot where reduction take place in the presence of H plus ions, that is H2CO3. At cathode, O2 plus 4H plus 4 electron gives 2H2O. The overall reaction being as 2Fe plus O2 plus 4H plus gives 2Fe2 plus 2H2O. E of cell is 1.67 volt. Fe2 plus ferrous ion oxidized by O2 to form ferric ion Fe3 plus, which comes out as rust Fe2O3.xH2O. Thank you to listening this podcast. This podcast is brought to you by Chemistry Notes Info, an innovative platform to learn chemistry at www.chemistrynotesinfo.com. If this website not works, you can alternatively visit our blog www.chemistrynotesinfo.blogspot.com, or you can also join us at Facebook, Instagram, YouTube, Telegram to get more PDF notes, infographics, quizzes, and many more chemistry content. Thank you to listening this podcast.